Okay. Next is question number 20. Yes, question number 20. Next is question number 20. He is asking high state noise margin of standard TTL. High state noise margin of standard TTL. High state, high state noise margin. High state noise margin of standard TTL. Standard TTL. High state noise margin of standard TTL and 5 volt CMOS logic gate and 5 volt CMOS 5 volt CMOS logic gate. 5 volt CMOS logic gate is what? If you will see here high state noise margin for standard TTL. Let us see for standard TTL. Okay, so this is my TTL, transistor logic. Yes, transistor logic. If you will see the noise margin, first of all, you see here V in. Okay, this is my, let us say this is my VDD. Okay, and here is somewhere, here is my what output, V out. Okay, V out. Now, so let us say this is my VDD. Okay, so now here, somewhere here, this is my VIH input, maximum high input voltage. Okay, so and this is my forbidden zone. Okay, and here is VIL. Here is my VIL, and somewhere here is my VOH. What? VOH, maximum high output. Okay, so and somewhere here is my, if you see here, VOL. Okay, this is my VOL. This is for TTL. This is for what? TTL. If you will see for TTL, TTL at input side, this is from 0 volt to 0 volt to 0.8 volt. Okay, 0.8 volt at input side. And for logic 1. Okay, for logic 0, for logic 0. Okay, and for logic 1 at input side it is from 2 to 5 volt. Okay, 2 volt to 5 volt for logic 1. For logic 1 at output side, if you will see, it is from 0 volt to 0.4 volt. Okay, this is for logic 0, and at output side for logic 1 it is from 2.7 volt. 2.7. Okay, so it is from here, this side, 2.7 volt. 2.7 volt to 5 volt. 5 volt. Yes, 2.7 volt to 5 volt. So this is my VIH. This is my VIH, 2 volt. This is my VOH, 2.7 volt. And this is my VIN. This level is my VIN. And VOL level is here. Okay, so this is my VOL level. That is 0 to 0.4 volt. 0.4 volt. Okay, so this is what, this is at input side. This is at input side. Okay, so this is at input side and this is at output side. Okay, input side for TTL 0 to 0.8 volt, and for logic 0, and for logic 1 2 volt to 5 volt. 2 volt to 5 volt. This 2 volt to 5 volt for logic 1. Okay, this range, in this range it will give logic 1. Okay, logic 1. In this range it will give what? 0 to 0.8 volt. It will give logic 0. Logic 0. If you will see same for output side, it will give logic 0, 0 to 0.4 volt. 0 to 0.4 volt. At okay, for logic 1 it will give output, it will give logic 1 from 2.7 volt to 5 volt. Okay, 2.7 volt to 5 volt, it is logic 1, but at input side it is for larger. Okay, this range is large, at output side this range is small. Similarly here, input side large, output side small. So therefore noise margin high is what? VOH minus VOL. VOH minus VOL. What is VOH? 2.7 minus how much? 2 volt. 2 volt is equal to how much? 0.7 volt. Yes, this is my noise margin high. Yes, noise margin low is how much? if you see noise margin low for TTL, TTL is what? VIL minus VOL. So this is how much? VIL minus VOL is nothing but VIL is point 8 minus zero point 0.4 is equal to what? Zero point 0.4 volt. Yes, this is 0.7 volt, this is 0.4 volt. So my noise margin, this is highest noise margin, this is lowest noise margin, but in option 0.7 is nowhere. Okay, so therefore 0.7 is not there given in option. Only option is given for low noise margin, it is zero point 0.4 volt. Okay, 0.4 volt. Okay, so now 0.4 volt, 0.4 volt, A and B. Now we have to check for CMOS. For CMOS, if you will see here, for CMOS is what? CMOS. Let us see for CMOS here. Okay, we will draw for CMOS. For CMOS, this diagram is same. Just we have to change this value. Okay, other is same for CMOS. If you will see for CMOS, this is TT. This is now it says CMOS circuit. For CMOS circuit, if you will see logic 0, in case of CMOS is 0 to 1.5 volt at input side. Okay, at input side. For logic 1, it is from 3 volt to 5 volt. Yes, 3 volt to 5 volt. Now see at output side. At output side for CMOS, logic 1 is from 0 volt to 0.05 volt. 0.05 volt. This is my logic 0 for in case of CMOS. and for logic 1, at output side range is from 4.95 volt to 5 volt. Yes, this is for what? Let us write this. This is here 0.05 volt. Okay, so this level is my VOL, and this is my VIH, and this is my 4.95 volt. Okay, for logic 1 at output side, and it is my VOH. Okay, this is for CMOS. Yes, CMOS operation. So this VDD, this input side range and output side range for logic 1 and for logic 0. Now if you see here noise margin high. For CMOS, noise margin high is nothing but VOH minus VOL. Okay, how much is this VOH? VOH is nothing but, if you see here, 4.95 minus VIH is 3 volt. So this is how much? 4.95 3.00. This is 9. This is 1.95 volt. Okay, so this is my noise margin high. For noise margin low, if you see here, noise margin low is what? Noise margin low is nothing but, this is VIL minus VOL. Yes, VOL. How much is this VIL? If you will see here, VIL is 1.5 minus VOL. How much is VOL? 0.05. Yes, so how much is this? 1.5 0.05 54, and this is my 10 4 1. So it is 1.45 volt. This is my noise margin low. Okay, so this is my noise margin low. So the option given as 1 volt, 0.4 volt, 1 volt. So 1 volt is given. 0.4 volt is nowhere. Okay, 0.4 volt noise margin is not possible for CMOS. At least there should be 1.45 volt. So noise margin, and it is given as in option 1 volt. So only according to option only 1 volt, but exactly high noise margin is 1.5, low noise margin is 1.45 volt. So therefore, if you see the option is what? 0.4 volt for TTL and 1 volt for CMOS. Yes, 1 volt for CMOS because 0.4 volt is not possible for CMOS. So this is about the noise margin. So the noise margin is what? Noise margin. It is the what? It is the range. Okay. So it is the range of operation where noise margin. It is the range of what? It is the range of noise. Okay. It is the range of noise. Okay, which will not affect the operation of what? Operation of this logic circuit. Okay, which will not affect the operation of logic circuit. Okay, maximum noise margin and minimum noise margin. Okay, so noise margin is nothing but it is the it is how much, up to how much range of noise, up to how much range of noise over logic circuit will work properly. Okay, without any impact of this noise is nothing but over what? Noise margin. Okay, noise margin means noise margin means how much margin you have about noise, so that so that your circuit is working properly. Okay, without any effect. Okay, without any effect on the operation. Okay, so the that is what noise margin is the range of noise margin. It is the margin of means how much margin the circuit how much margin the circuit has about noise, so that it will work properly. Okay, it will work properly without impact of this noise on the circuit. Okay, so this is about noise margin. As we have seen this. Okay, up to this range it will work properly here. Okay, low noise margin, high noise margin, up to this range it will work properly without impacting the operation of what? Logic circuit. Okay, so this is about noise margin. Or you can say up to what extent, we can we can tolerate the noise. Okay, up to what extent the circuit can tolerate the noise. Okay, during its operation means up to what extent the circuit will work properly. Okay, without the effect of what? Noise. Okay, so that it can tolerate. So this is all about up to tolerance. Okay, how much tolerance the circuit have about noise. So now